Hello, everyone. My name is Brendan, and today I'll be talking about Alzheimer's disease, the most common form of dementia. And by the end of this presentation, you'll be able to explain the biological brain changes that occur with Alzheimer's and discuss current research on how to prevent or slow its progression. Now, before we dive in, it's important to understand that Alzheimer's is not simply getting older. While some memory changes are normal with aging, Alzheimer's is a distinct disease with unique changes happening inside the brain. So then what is Alzheimer's? Alzheimer's disease is a progressive brain disorder that slowly destroys memory, thinking skills, and eventually the ability to carry out daily tasks. Over time, people may lose independence entirely. Unlike normal aging, Alzheimer's involves specific pathological changes, simply meaning changes that can damage the brain, such as buildup of abnormal proteins and the death of brain cells. These changes start years before symptoms are obvious. Alzheimer's typically progresses through three main stages. Early stage, symptoms are subtle, maybe forgetting recent events, misplacing objects more often, or struggling to find the right word. People are often still independent, but they notice changes in themselves slowly. Middle stage, confusion grows, tasks like managing finances or cooking becomes more difficult. Recognizing familiar people may also become a challenge. Late stage, communication becomes very limited, and individuals often need help with basic daily functions such as eating or even moving around. At this point, full-time care is usually required. It is important to remember that progression varies from person to person. Some decline quickly, while others experience slower changes. The two hallmark features define Alzheimer's are beta amyloid plaques, clumps of proteins that build up between neurons, blocking cell-to-cell communication, and tau tangles, twisted strands of tau protein that form inside neurons, preventing nutrients from moving properly along the axon. Over time, these issues lead to neuron death. As neurons die, brain regions shrink, especially the hippocampus, which is crucial for memory formation. This shrinkage can be seen in the brain scans and is one reason memory loss becomes so severe. Age is the greatest risk factor. Most cases occur after the age of 65. Genetics also plays a huge role into this, especially a gene variant, APOE, which increases the likelihood of developing Alzheimer's. But genes are not the whole story. Lifestyle factors such as heart health, physical activity, diet, and even social engagement influence risk. In other words, our we may not be able to change, our age or genes, but we can influence other factors. In recent years, scientists have been exploring the role of neuroinflammation, an overreactive immune response in the brain that may speed up damage. One exciting development came in 2023 with a drug called lecanemab. We're going to pretend I know how to pronounce that. It targets amyloid plaques and has shown promise in slowing cognitive decline. While it's not a cure and requires ongoing treatment, it represents a major step towards therapies that actually change the course of the disease rather than just treating the symptoms. Although there is currently no cure, research shows that certain habits may reduce risk or delay symptoms. Mediterranean style diet, rich in fruits, vitamins, whole grains, fish, and healthy fats. Regular physical activity improves blood flow and overall brain health. Cognitive stimulation, activities like puzzles, learning a new language, or playing music help you build cognitive reserve. Good cardiovascular health, managing blood pressure, cholesterol, and blood sugar also supports brain health. Think of it as what's good for the heart is good for the brain. In summary, Alzheimer's disease is marked by the buildup of harmful proteins, loss of neurons, and shrinkage of key brain regions. Genetics may set the stage, but lifestyle can make a big difference in risk. While there is no cure yet, breakthroughs like lecanemab give hope that slowing the disease is possible. The more we learn about prevention and early detection, the better equipped we'll be to fight this disease in the future. And thank you all for listening, and I'm happy to answer any questions.